Hi everyone, today I am going to do a small example that shows the power of Riskfolio XL to handle large portfolios. So for this example, we are going to work with a sample of here 468 assets and data starting in 2014 until the end of September of 2024. Okay, so first we are going to download the prices from Yahoo Finance. Load prices. We pass here the list of assets and then the start date and the end date. It takes some time because we are downloading the data from 468 assets. So it's going to take a little time. Okay, now we have the data from the 468 assets. So here we have all the data. It has 2,703 days of information. One recommendation is, because this database is too big, we are going to copy this database and paste as values. Okay, this is one recommendation to avoid the problem of to lose this data. Then, now we are going to calculate the returns. So rp.calculate returns. We are going to select here the prices. Okay, we have the returns, and here we have the returns of the 468 assets. Then so after we calculate the returns, we are going to create a portfolio that minimizes the variance. Okay, so here we are going to change this, and here the objective to mean risk, and here to Claravel. Well, the parameters of these, the values of these parameters are specified here in the Riskfolio and Riskfolio docs, are the same parameters from Riskfolio-Lib. Okay, so the objective functions are, for example, if you open portfolio models, in model methods, in the portfolio, here in portfolio optimization, for example, here portfolio optimization, model classic, RM, MB, objective sharp, Kelly none, is true. So you have here all the parameters. Maybe here I don't have the Kelly parameter, but I think that is specified. Yes, it is specified, this parameter. But also, well, we have here the parameters of the Riskfolio-Lib function. Okay, but by the moment we are not going to use this function. Also in the examples of Riskfolio-Lib, here you have a lot of examples here that you can check, with several examples of how to use Riskfolio XL. Okay, so first we are going to minimize the risk and here .3. We are going to use the function rp min risk optimize, and we are going to press here in the fx parameter, in the fx button here, and as a recommendation, because the sample of returns is too big, it's better to add the parameters of the expected returns, the covariance matrix, or well, the other parameters first, and then we have to add the returns information to avoid problems. Okay, so here we are going to add all the parameters here, and we can give in OK here, and we are going to have an error because we didn't add the returns information. So we add here the returns information, and the resulting portfolio that will appear is a little slow because we are using an open source solver. Okay, so to gain speed, it's recommended to use a commercial solver. Okay, here this is a portfolio that minimizes the variance. But as you can see, this portfolio is very big, and also it's difficult to watch the concentration of this portfolio. To see how this portfolio is concentrated, we can use a function that is called weight by class, where we pass here a portfolio, we pass here a table of asset classes. This table must have the first column the number of row of the table, the second column the tickers of the assets in the same, well, that are the same that appear in the portfolio, the sector, well, then another columns that means that has some classification. In this case, I am adding the column sector and industry, but you can add more columns like country, asset class, I don't know, kind of investment, I don't know. You are free to create labels to add constraints. And here we are going to add this, and first we are going to use, in the last parameter, we are going to put the name of the column that we are going to use to group the weights. So first we are going to work with sector. So here we have the asset allocation by sector, and then we are going to do the same but for industry here. Here we are going to copy the function, and here we write industry. Okay, here we have the concentration by industry. And also we can plot the composition here, rp dot plot pi of the first by assets, because it's a little small, we are going to increase the size here a little more. And here we have the concentration by asset. Here, I think that it's a good idea to increase a little more, and here more. Okay, well, we can see here that this portfolio is a little, is concentrated, very concentrated. This has a lot of assets, this portfolio. Okay. So here we have Verizon. Well, it's highly concentrated on Verizon. Then we can plot by p.plot by, we can plot by sector here, and here we have the classification by sector, but because it's too small, we can increase here a little the size of the plot, and here we have a better plot. And then also here below, rp.plot by here. And here we have the concentration by industry, but I am going to increase here the size of the plot. I think that a little more. We have to increase the width of the plot. Okay, and here is better. We can see the, I think a little more to see the concentration by, to see right the labels. Okay, so now we have a good graph that show here is the asset allocation by industry. Here we have the asset allocation by weights, by sector, sorry, and here by asset. So this is a very nice way to see the concentration of the portfolio. Also, we can change this to another risk measure, for example, the C bar, the conditional value at risk. It takes some time because in the case of the conditional value at risk, it considers the 2,700 scenarios. So it's a portfolio, well, it's a linear programming problem that is more complicated. So for this reason, and also we are using an open source solver. So for this reason, it takes a little more time. And now we have the new asset allocation that minimizes the conditional value at risk. To improve the performance or the speed of the optimization, we can change to a commercial solver like Mosaic. And with Mosaic, the asset allocation is a faster process. It's faster. So now, for example, we can calculate here the return divided by the conditional value at risk. And here we have the allocation also. Here we have changed to the original Sharpe. Also here we can add another risk measure, for example, the mean absolute deviation. Here is the mean absolute deviation that is closer to the variance. Also, we can use the relativistic value at risk. This is a more complicated model, so maybe it's going to take a little more time. Because we are optimizing a portfolio with 468 assets. So, but using Mosaic is faster, but also the relativistic value at risk is a model a little more complicated. And here we have the portfolio that maximize the return divided by the relativistic value at risk. Also, we are going to go back to the mean variance because it's more common for users to use the volatility as a risk measure. And here the objective is the minimization of risk. And then we're going to see the concentration here of this industry. For example, here the high concentration on consumer staples, in healthcare, mainly in consumer staples, also in pharmaceuticals. Here a high concentration, so maybe we can add some constraints. Here, for example, we are going to add two constraints. One constraint, for example, here we have to put false type. We are going to make a constraint in all a classes constraint. Type is all classes. all classes. This is going to be sector, and here industry. The position is, well, here we don't need a position, and I need that in both cases, all classes. In the first case, I am going to put an upper bound of 15%, and in the second case, maybe an upper bound of 8% per industry. And then we have to, we are going to delete this just to avoid the problems. And we have to open this. And here in constraints, we have to add the constraints, this table of constraints. And here in asset classes, the table of classes. So here we go. Okay, we have the problem, but if you remember, you have to put here the returns. And then we are going to recover a portfolio that meet the constraints. You can see here the maximum value is 15%, as you can see here in the Excel. And here below, the maximum value of this range is 8%. As we can see also in the chart, 8%, 8%, the maximum concentration. Also 15%, the maximum concentration here. Okay, so, and also, for example, we can calculate, for example, the standard deviation of this portfolio, the STD, using the function RP risk function here. This risk function is a function that allows us to estimate the returns. We have to put here the weights of the portfolio here in the returns. We need to put here the returns. Sorry, and well, for other risk measures, we need more parameters, but in this case, only with these two. And here we have the estimation of the volatility here of the mean risk portfolio. Maybe if we can see what happened if we change this to sharp. But in the case of the mean risk, the volatility is a minimum. But in the case of the sharp, we have a volatility of 1% here. And this portfolio also meets the other constraints. So maybe we can add a constraint here. Here below, we have an upper depth parameter. This is the parameter for the maximum level of volatility. Maybe we can put here a maximum level of, which is the value is 1%, 1.1%, 0.1. So maybe 0. This is a 0.9%. Yes, 0.9% as a maximum level of volatility. So let's see what happened here. And here the portfolio has a maximum level of volatility of 0.9. I hope this, and also you can do this for other risk measures. So you have the free, also you can change this to allow short positions, and you have the freedom to do whatever you want also with the other models. And all this work also, as you can see, for large portfolios. So Riskfolio XL is not only for academic purposes, also is designed for real applications. So I hope you have enjoyed this small tutorial of large portfolios, of how to handle large portfolios with Riskfolio XL. And see you next time. Bye.